Welcome to this exciting video tutorial on building a 3D soccer game. I'm thrilled to guide you through the process of creating an engaging soccer game using Java and a popular 3D graphics library. Throughout this video, we will cover everything from setting up your development environment to implementing various gameplay mechanics. So, buckle up and let's get started. First, let's set up our development environment. We will need to download and install the Java Development Kit, JDK, and a suitable IDE for Java programming, such as IntelliJ IDEA or Eclipse. If you haven't done this yet, be sure to follow the installation instructions on the official websites. Next, we will need a 3D graphics library. For our soccer game, we'll be using libgdx, a versatile framework that simplifies game development in Java. Head to the libgdx website and follow the setup instructions to integrate it into your IDE. Now, let's create a new libgdx project. In your terminal or command prompt, navigate to the directory where you'd like to create the project and run the following command, gdxsetup.jar. This will start the project generator. You'll be prompted for various details. Name your project, choose a package name, and select whether you want to include support for Android and/or iOS. Once the project is generated, open it in your IDE. In the project structure, you should see a folder named Core. This is where we will implement most of our game logic. Start by going to the gamescreen.java file in the core folder. Here, we have a basic game structure. We have overridden the create method where we can initialize our game assets and the render method where we will update and draw our game objects. Let's move on to loading our 3D models for the soccer field and players. libgdx supports various 3D models with the help of the Model Loader class. We will create a new method called loadModels. Inside this method, we will define a model loader and load the soccer field and player models. Make sure you have the required model files saved in the Assets folder. In the loadModels method, we define soccer field model and soccer player model as instances of model. We use a model loader to load the models from the Assets directory. Make sure to replace soccer_field, G3DJ and soccer_player, G3DJ with the actual file names of your models. Now that we have our models loaded, let's implement basic movement controls for our soccer player. We will use the keyboard input to move the player on the field. First, we need to import the input processor class and implement it in our GameScreen class. In the keyDown method, we check if the W key is pressed to move the player forward. You can implement additional controls for other directions by checking for other key inputs. As we build more functionality, we will refine this control setup. Now let's move on to rendering the soccer field and players in the render method. We'll update the rendering code to include our models and process transformations for animations later. In this updated render method, we clear the screen and then begin rendering our models with a model batch. Don't forget to set up the camera to view the scene correctly. We will discuss camera setup in the next section. Next, let's implement basic camera controls that will follow the player. We will create a camera that tracks the player's movement around the field. New members for the camera will be added to our GameScreen class. In the create method, we initialize the camera with a perspective view. We position it to get an overview of the soccer field and player. We will incorporate logic to update the camera position to follow the player based on its movements. To update the camera position in the render method, we can add the following lines of code. The camera should always look at the player, so after moving the player, we will update the camera position accordingly. With this code, the camera will follow the player's position on the field, ensuring they're always centered in the view. Experiment with the camera elevation and distance to find the best angles for viewing the gameplay. Next, let's implement ball mechanics. We'll create a new model for the soccer ball and handle the ball's physics. Load the ball model similarly as we've done for players and the field. Now, let's implement basic physics for the soccer ball. libgdx has a Box2D extension that allows us to manage physics simulations easily. First, we need to set up Box2D in our project. We'll create a physical world for our game where the soccer ball can interact with the environment. Set up the world and ball body in the create method. The ball's position should be synchronized with the ball instance model instance. The soccer ball's physics body is now created, and we're setting its initial position above the ground. We can now synchronize the ball's position with the visual model instance each frame. The world.step method updates the physics simulation and the ball's position is set using the position data from the physics body. Now you can press the player's movement keys to see the ball fall and react to gravity. Next, let's build the scoring system for the game. We will define a simple scoring logic to detect when a goal is scored. We check if the ball has crossed the designated goal line and increment the player's score accordingly. Handle the reset method to put the ball back in its original position. Now that we have basic scoring implemented, let's display the score on screen. Use a bitmap font to render the score in the game view. We initialize the font in the create method. Now let's draw the score in the render method along with the current score values. With this line added to our render method, you should see the scores displayed at the top of the screen during gameplay. Now that we have some basic game mechanics in place, let's take a moment to refine the user experience. Consider adding sounds to enhance immersion in the game. We can use the sound class in libgdx to play sound effects when a player kicks the ball and when a goal is scored. We can play these sounds at appropriate events in the game. For instance, when the player initiates a kick, we can call kickSound.play, and when a goal is scored, call GoalSound.play. In this way, we enhance our game with sounds that correspond with player actions, making it feel more dynamic. Finally, let's discuss packaging and distributing our 3D soccer game. libgdx supports cross-platform development. We can package our game for desktop, Android, and iOS. Open the desktop project in your preferred IDE and create a runnable JR file. Once you have your runnable JR, you can distribute it over platforms. For mobile platforms, follow libgdx's specific instructions for Android and iOS builds. And there you have it. We've built a basic 3D soccer game using Java and libgdx. Make sure to continue enhancing your game with additional features such as AI opponents, different camera angles, and more detailed graphics. The sky is the limit. Thanks for watching. If you enjoyed this tutorial, don't forget to like and subscribe for more game development videos. Until next time, happy coding!